Good afternoon, everybody. Welcome to another exciting afternoon of organic chemistry, Chem 170, with your host, me, Dr. White. Now, a couple things. Something happened with Zoom. I just noticed, and it's never happened to me before, but then I think I might have done something different this time. I'm going to be having to set up new Zoom login for our office hours starting this afternoon, and also for next week and the rest of the semester's uh, Zoom meetings. I don't know what happened, but anyways, I will send out an email and put an announcement. The new link will be the same password for our office hour this afternoon, and also tonight, or not tonight, next week, our classes. I'll also change the link in my syllabus, and I'll change the link on the first page of D2L. I don't know, say Friday the 13th or what, but anyways, I thought I'd just tell you that. Next, important information or announcement. I like that. Next Wednesday will be test number 3. And I just sent out earlier within the hour, and let me open it up. Like I said, well, let me make this visible to you. I'll change the link right here and here. So on Monday, you'll be able to get into class, and also I'll send out an email. But anyways, if you notice, we have, and thumbs up people, can everybody see test number 3 information on your screen right now? Thank you, Kristen. All right, test number 3 will be a week from today, 4/13/22. And I'll give it online just like I've done test 1 and 2. I'll load up sometime Tuesday afternoon a password protected PDF file for test number 3. And sometime on Wednesday, 4 p.m. or earlier, depending when we end class, I will send out an email with the password to for the test number 3 PDF file. You'll have until Thursday morning, 11 a.m. to finish test number 3 and upload your test number 3 answers to assignment area D2L. Remember, if you don't have a printer, you can write it out, and I will have instructions like I did for test 1 and 2, how to make a PDF file with your cell phone if you don't have a scanner. And it should take you about 40 minutes, but why don't you take it up to an hour and a half or so? Either you know it or you don't. All right, test number 3 has 9 pages, 10 problems. Some of the problems are multiple part. In this class, I have never and never will give multiple choice problems. It will cover carboxylic acids, esters, carboxylate anions, amines, amine salts, my favorite quaternary ammonium salts, amides, and heterocyclic compounds. Now, here's the point breakdown. General knowledge, 7 points. Nomenclature, 38. Reactions, 60. And don't forget on the reactions, I think I have 3 or 4 synthesis problems, which are give the starting materials. Now, like all my tests, this test, like all my tests, will not be open notes. I have things in there that I can tell when somebody's been, that's called cheating. So please don't. On Monday, I will review all the material on test number 3. We will have our regular Zoom meeting on Wednesday and a lab. And after the lab, I'll send out the password for test 3. And as always, have a great rest of the week. Gehen gesund, which means go in health. So, any questions about test number 3 coming up a week from today? Going once, going twice. All right. And as I mentioned earlier, I had a problem with Zoom. I'll be setting up a new link, same password for our office hour and also for the Zoom meeting for our class and lab next week. All right. Good news. I was looking at the schedule and where we are and everything. I've caught up. Actually, we're a little ahead of the game. So today, you'll get out early. Actually, in real life, if we were face-to-face, I'd lecture for 50 minutes. We do the lab and you go home. And today's lab, you get home early. So we're right on schedule now. Oh, excuse me. All right. I promised today I would go through the practice problems for the amines, quaternary ammonium salts, amine salts, amides, heterocyclic compounds. But before I do that, did anybody pick up a bottle of vinegar and think, wow, that bottle has acetic acid, which is a carboxylic acid? Did you pick up a bottle of ketchup or mustard or a jar of pickles and see it's got vinegar? And you know now that vinegar has acetic acid, which is a carboxylic acid. Or did you happen to be in a big box store, or maybe you have it at home, and pick up a bottle of nail polish remover? Notice I removed my nail polish. Actually, when I was a kid, men used to, in the barber shop, get a clear coat on their nails all the time. They actually had manicures in the barber shops. My grandfather used to do that. My brother-in-law did that too. I never did. My father didn't either. But a lot of men did do that. But anyways, if you look at the bottle of nail polish remover and see it has ethyl acetate, which is an ester, or if you happen to do your laundry and look at the box or the bottle of fabric softener and see it's got a quaternary ammonium salt in it. Remember, organic chemistry is all around you, and it won't hurt for you to think about it outside my class. Oh, one more last thing. It's getting to be spring soon, I hope, even though calendar-wise it is outside. Well, they're talking snow for this Friday. But anyways, that looks weird. But anyways, snow in April is weird. But eventually it will get warm and we'll have flowers. When you smell the flowers, do you know you're smelling esters? Next time you smell a rose, what are you smelling? Esters. See, organic chemistry really is all around you. All right, let's go through the problem set. Okay, now something different for test number 3 in nomenclature, because I only asked you to learn the amines and quaternary ammonium salt and amine salt common names. I will give the IUPAC or the common name for the following. And remember always, when you look at an organic molecule, look for what's different, what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond, should get your attention like that. All right, let's look at A. Ooh, what's different in nitrogen? Remember, amines have 3 bonds to them, and it has an R group. The common name, what's the R group on nitrogen? Butyl. And actually, this should be N-butyl. I'm going home. I am home. That should be N-butylamine. Next one, nitrogen again. Here we have ethyl and isopropyl. Now it can be either order because this is a common names and there are no set rules. And that's ethyl isopropyl or isopropyl ethylamine. Now, when R is a benzene ring and H2 on a benzene ring, the common name became the IUPAC name, and they're both the same aniline. Now, I got carried away, cross off D, and let's continue. E, what do we have? What's, a nitrogen with a plus charge. Notice there's 2 + 2, 4 alkyl groups on there, and a halogen anion. That's a quaternary ammonium salt. And how do you name those? You name each alkyl group, then add the words ammonium halide, Cl minus chloride, Br minus bromide, I minus let's try it again, I minus iodide. And that's a chloride. Notice I have 2 methyl groups, 2 ethyl, and you can have any order, diethyl, dimethyl, or dimethyl, diethyl, ammonium chloride. Now, when there are less than 4 groups on there, you have an amine salt. And guess what? You name them the same way. And here we have an N-propyl, and notice amine salts and quaternary ammonium salts have 4 covalent bonds to nitrogen. And here we have N-propyl ammonium chloride. Now here, draw the condensed structures for the following organic molecules. An amine, it only has 1 group on it, ethyl. I have that. Remember, in amines, there's 3 bonds. So 1 R group, 2 hydrogen, 3. Here we have amine, start from the right, move left, ethyl T or tert-butyl, and doesn't matter which side the ethyl and the T-butyl group is on. And once again, 3 bonds to nitrogen in amides and amines. So I have 2 alkyl groups, 3 minus 2, 1 hydrogen. All right, I got carried away. Remember, I promised I wouldn't have any where you have more than 1 alkyl group. Well, this one with the aniline. So just cross that off. It will never be on a test. Now, let's look at D, because this is a molecule very close and near to my heart, because it helped pay my mortgage, a couple of cars, got me around the world. Because the company I work for made this compound. And it's ditallow, and we show a tallow group by R sub T. And you've already learned that it's with or without a double bond, 16 to 18 carbons, and dimethyl. This is one way of drawing it. Ammonium chloride. This is quaternary ammonium salt. Now, another way to draw that would be correct on a test. Did I tell you I'm that close to the person grading the test? Me. Ditallow, dimethyl. You don't have to put the charges down. I will. Ammonium chloride. So 2 sides have R sub T and 2 sides have methyl. It doesn't matter which. And you have the chloride. Now, remember, even though we put this here, this is not bonded to the methyl group. It's really bonded to the nitrogen by an ionic bond, not a covalent. Oh, by the way, E cross off, and F is methyl tert-butylamine. Start from the right, amine. There's T-butyl and methyl group. And here are 2 ways you can draw it. All right, let's look at reactions. And the question is 3 points each. Draw the condensed structure for the organic products for the following reactions. And here we have ammonia plus carbon, a halogen, ammonia alkyl halide base, you get a primary amine. What's our methyl? Here, an amine, methylamine, primary amine, carbon-carbon alkyl halide. In the presence of base, you get a secondary amine. What's our methyl, our prime isopropyl? Remember, nitrogen, all these cases, A, B, and C, the nitrogen bonds to the carbon in R prime that has the halogen associated with it or bonded to it. Again, the nitrogen bonds to the carbon in R prime that has the halogen on it. That's very important. Remember that. Hint. Then C is a reaction near and dear to my heart, and that's a tertiary amine, two phthalate groups and a methyl. Carbon halogen, alkyl halide base, you get a quaternary ammonium salt. And one way to write this dimethyl ammonium chloride is this way, and you just saw the other way you could write it. Now, amines are bases, and bases accept protons, H plus. So if you have a secondary, primary, or tertiary amine, HX, you get amine salt. So here I have a primary amine. Notice I have two hydrogens. I'm going to add one more. I now have 4 to that nitrogen, 3 hydrogens, 1 methyl group, plus charge, but you don't have to show it, and needs an anion chloride. And if you look at F, tertiary amine, HX, here, add 1 hydrogen, because there are already 3 bonds to nitrogen there, and the counter anion is iodine. Be sure to cross off G. I got carried away. I wouldn't put that on a test, but it's still an amine making amine salt. By the way, for G, that's diethanolamine. That's the common name. And that's used in cosmetics and personal care products to adjust the pH. Why? Because it's a safe base to add to neutralize any acid in the formulation. All right, continuing on. If we look at H, I don't need glasses. Well, maybe reading glasses, but H, what do we have that's there? Carbon, nitrogen, triple bond. And that's a nitrile, which I'll never ask you what that is. Remember, triple bond, 3 bonds between carbon and nitrogen and nitrile. 2 of them are pi bonds. And you know what you can do with a pi bond. Take excess hydrogen, a catalyst, which can be nickel, platinum, or palladium, and you break the 2 pi bonds, and each atom of the triple bond gets not 1, but 2 hydrogens. Well, here R is methyl, and the only thing I did here is I put the hydrogens on the 2 atoms instead of writing it like this. Now in I have a benzene ring, but it's not going to react with hydrogen under these conditions, but the nitrile will, and here's what you get. And in J, I just did a big, scary R group. But if you know it's a nitrile, it's not big and scary. All right, let's move on to K. What do we have here? Hydroxyl group and a carbonyl, R group, carboxylic acid, carbon nitro, an amine. What happens when you react the carboxylic acid with an amine? You make an amide. Now remember, I don't have it here, and I should have, bad Dr. White. So let's go to the whiteboard. Actually, it's White's whiteboard. And what I forgot to do was this. Remember, in this reaction, our prime and our double prime can be hydrogen, or they can be both alkyl groups. So if they're both hydrogen, this would be NH3 ammonia. But here it's a methyl group. R prime is methyl, one of the hydrogens are double prime, and you form an amide. What's our methyl? It's attached to carbonyl, carbon double bond to oxygen. And you have a nitrogen on there is hydrogen and methyl. You can change these. It doesn't matter which side it's on. And in that's L, sorry about that, we have a carboxylic acid. What's R? Benzene ring. Now, NH3, R prime and R double prime are hydrogen. And you form an amide where R is a benzene ring and R prime and R double prime are hydrogens. I have some more examples here. Now, let's look at N. What's important about N? In the amide, the carbon that has the bond to the nitrogen, the amine, will be the same carbon or that has the carbon to nitrogen in the amide. So notice how you have an isopropyl group here for your amine. The group on the nitrogen, the atom in the amide is an isopropyl group. All right, let's continue on. What do we have in O or P? Let's look at P. What do we have? Ooh, carbonyl, nitrogen. On nitrogen, there's stuff. On the carbonyl, there's stuff. It's an amide. What are we reacting with? HCl. Remember, that's an acid. Why am I using HCl in these examples? Because that's the acid in your stomach. And here we have an amide, HCl water. A general reaction says you get back the carboxylic acid you would have used to make that amide, and you get back the amine salt of the amine you would have used to make that amide. Why? Because as soon as you make the amine from this reaction, amines are basic, acid is acid, and the quickest reaction in all of chemistry in nature is an acid-base neutralization, which is why you get the amine salt. So if we look at P, R is a benzene ring, and the carboxylic acid is benzoic acid. And R prime is methyl, R double prime hydrogen. Again, I didn't write down, oh, I'm getting lazy. R prime and R double prime can be hydrogen. I better get unlazy. And R prime and R double prime, actually R2, but I'm not going to ever do that on a test. But R prime and R double prime I can, and they can be in real life, one or both, or none can be hydrogen. And this example one is. So you get this amine, carboxylic acid plus this amine salt of the amine I would have used to make that. And here, R prime is methyl, R double prime is hydrogen plus two more. I could write it this way or this way. Either one would be correct. Organic chemists would write the top one because we're lazy. And it's easier. And notice here on Q, wow, I gave you some really big, scary R groups in R prime. But it's an amide, HCl and water. You get back the carboxylic acid you would have used to make that amide, plus the amine salt of the amine, R prime methyl, R double prime benzene. And you put two more hydrogens plus charge, Cl minus. You don't have to show those charges, but I always will. All right, this is acid hydrolysis of an amide, not with this molecule, but later I'll teach you that's how your stomach breaks down protein. Now, if we look at R and S, and I got lazy again, remember R prime and R double prime can one, both, or none be hydrogen reacting with sodium hydroxide and water. And for this reaction, for this class, I'll stick to sodium hydroxide. It's a base. And this is base hydrolysis of an amide. You get back not the carboxylic acid, but the carboxylate anion of the carboxylic acid you would have used to make that amide, plus the amine you would have used to make that amide. Why the carboxylate anion? Because this, if you got the carboxylic acid in the presence of base, that will immediately form the carboxylate anion. So if we look at S, amide, remember carbonyl, nitrogen, R is a benzene ring, R prime is methyl, R double prime is hydrogen, and here's what you get. And in T, I have, a very, very fancy, scary molecule. But if you know what to look, what functional group, it's not scary. And therefore, this is an amide. R is this group here, 1, 2, 3, 4, 5 carbons, a straight chain. On N, R prime is methyl, R double prime is benzene ring, or you could switch them, doesn't matter. And you get back the carboxylate anion of the carboxylic acid here. You would have used, here's my R group, carbonyl, O minus, Na plus. You don't have to show charges, I will. Oops. Uh-oh. Mistake time. The second N should be a hydrogen, or should be a methyl. That should be a hydrogen, not a nitrogen. This should be a hydrogen here. All right. And here, number 4, I gave you some actual practice problems for making doing the synthesis problems. And as always, you need to know your general reactions. And if we look at B, what do we have? Quaternary ammonium salt. I forgot the arrow and the word base here. Boy, I got lazy on this one. And how do you make a quaternary ammonium salt? Tertiary amine alkyl halide in the presence of base, which I forgot to put the arrow, and base, sorry. And what's the anion? Halogen is chlorine. So Rx, I could say one of these methyl groups is R triple prime. The other methyl group is R, and my two ethyls are R prime and R double prime. And if that's the case, this right here would be what I would react. Now, there's more than one way to do it. You could say the two methyl groups are R and R prime, and one of the ethyl groups is R double prime, and the other one is R triple prime. Then the top right by the letter B is the reaction starting materials you would use. And either one for my class, for you would be the same, but the second one, I believe, using cost accounting and my knowledge of chemical prices, would probably be a little less expensive for the raw materials, which would allow you to maximize your profits. That's what we do in industry. And if I look at C, what am I making? A primary amine. How do you make it? What do you react with hydrogen excess and nickel catalysts? I forgot to put down catalysts can be nickel Ni, platinum PT, or palladium PD. And you start with a nitrile. And what's our two carbons? And here's the nitrile. Remember, the carbon in the primary amine bond to the nitrogen will be the carbon in the nitrile. And here, what do you react with acid and water to get a carboxylic acid and an amine salt? And the answer is an amide. What's our ethyl? What's our prime and propyl? And one of the hydrogens are double prime, which would look like this. And you can have the same thing with base and water. What do you react with base and water to make a carboxylate anion and an amine? And the answer is an amide. And what's our ethyl? It's on the carbonyl. And in the amine, the alkyl group is our prime, and one of the hydrogens will be our double prime, and that's what you get. Any questions? I'm all ears. You know, I can wiggle my ears. It's my claim to fame. Not really. All right. You know something? You people need a pick-me-up. And you know what's a good pick-me-up? It's time to play that fun game. Circle and name the functional group, 2 points each. So let's have some fun. Let's get to the right screen too. And there's 4 for you to have some fun with. And the question is, circle and name the functional group or groups in each of the following, 2 points each. Have some fun. Oh, excuse me. Big yawn just escaped. Catch it, bring it back. And for those who came in late, after class today, I've got to reset up the Zoom lecture meeting and our Zoom office hour. So if you want to come to my office hour today, check your email. And once I have it set up, I'll send out the new link. It'll have the same password. I'll also change that in D2L, and maybe today or tomorrow, I'll change it in my syllabus also. Remember, we're playing that fun game. Circle and name the functional group or groups, 2 points each. I like that special effects. Oh no, it's Bad Humor Wednesday. That was pretty bad. I'm ambidextrous. Lucky we're not in a classroom because I'd be doing my rabbit thing with the shadow on the whiteboard. And if you finish early, please be patient. I try and give everybody time to finish. All right, I think everybody's done, so I better get to work. All right, look for what's different. Ooh, oxygen, nitrogen. They're on a carbonyl with nitrogen. What is this? It's an amide. Remember, amides have this functional group structure. Remember, our prime and our double prime, one, both, or none, can be hydrogen. Let's look at B. What's, ooh, a nitrogen, carbons here and here, and a hydrogen. What is that? An amine. And a lot of people get amides and amines confused. They're different. And remember, amines, primary, secondary, tertiary. And again, R prime and our double prime can be hydrogen. Are we done? Oh, we're not done. There's oxygen here and here. Remember, look for what's different, what's not carbon, and what's this? It's an ester. How do we know that? R group, carbonyl, oxygen, R prime, ester. Let's look at C. Ooh, a nitrogen has 1, 2, 3, 4 groups on it with an anion. And what is this? That should be 2. Sorry about that. That's a quaternary ammonium salt. Since let's go over down here where I have more room. And what do we have? A quaternary ammonium salt has 4 different groups, or 4 groups total. They can be the same or different, on a nitrogen with a halogen anion. Are we done? Oh no, there's oxygens here and here. Carbonyl, hydroxy group carbons. What's that? A carboxylic acid. And let's go to D. Now you know it looks like D. Ooh, oxygens here and here on a carbonyl, oxygen, carbons, carbons. What's this? Ester. Ooh, nitrogen. Carbons here. And notice I have 3 hydrogens and a plus charge and a halogen. And this is an amine salt. Where R prime and R double prime can be hydrogen. In this case, one of those R prime and also R double prime are hydrogens. And that's how you play that fun game, circle and name the functional group. I normally go to 150, and then we take a 5-minute break, but this is a good time to take a break. It's 1:46, come back at 1:51, and we will continue. I get up and exercise, stretch. I have to turn on my mic. Time to start again. Now, it was the last night or this morning I was thinking, and I don't think I mentioned this, so if I did, it's instant replay. If I didn't, well, now I will. How many of you have heard of vitamins? And vitamins got their name from long ago. Chemists thought there's certain compounds, molecules, organic molecules that are vital to our life. And at the time, they thought all the ones that they found so far that were vital were amines. So they called these specific compounds vital amines. Organic chemists are lazy, and vital amines became vitamins. Now, it turns out not all vitamins are amines because they made a mistake, or maybe they just didn't find them all at that time. But the name vitamin comes from the fact that they thought the vital amines, vitamins, were essential to keeping you alive. And since then, they found out that not all vitamins have amines in them. Now, one of the things I like to do before we do our lab is, first of all, close this, because I keep on clicking on it when I don't want that. What I do want is this. All right, one of the things I like to do right now is go through a couple of reactions that students have trouble with on test 3. And if you haven't figured it out by now, practice makes perfect. But before I do that, a quick commercial or request from Dr. White, me. This summer and this fall, I'll be teaching Chem 170 again, online. If you know anybody who needs organic chemistry one semester and they're anywhere on their planet with internet access, you don't have to be in the Chicagoland area, tell them about it. Because this summer, just like right now, and also this fall, just like right now, I like the hand gesture right now, I will be teaching Chem 170 totally online like I'm doing this semester. That's one thing. Now, the other thing is, I think it started or will start next week. There'll be the evaluations from ECC that you'll do for me in this course online. I'd like to ask everybody, please take that. Also, if you like what I did this semester, go to ratemyprofessor.com and put something down. Again, if you like what I did this semester, go to Rate My Professor and put something down. And if you didn't like what I did this semester, go there too and put something down. All right, let's get back to work. Now, one general reaction, hold on. Is to make an ester. And I'm going to let you have some fun today. Hello? Can everybody hear everything? Can everybody see everything? Give me a thumbs up if everything's okay. Thank you, Vivian. And why don't you try this one? Give the organic product or products for the following reaction. 3 points each. And if you came in late, don't forget, I have to reset both our Zoom meeting and our Zoom lectures, and I'll send out the new link later this afternoon within 45 minutes after the end of this class. Both, I'll do that on announcement, email, and by tomorrow also be in the syllabus. And by the end of the day, if not before 5 o'clock, for sure, not the end of the day, I will also have the links on the first page of D2L corrected. All right, I think everybody's done, so let's do this. And how do you do that? You identify the functional groups, which is why we played the game, circle and name the functional group. Because if you can't identify the functional group, you're not going to be able to name it. You're sure not going to be able to do reactions with it. What's different? What's not carbon? What's not hydro? Ooh, carbonyl hydroxyl carbons, carboxylic acid. Hydroxy group on carbon, alcohol. Acid catalyst, what do you get? An ester. And what's our, right here, what's our prime? Oops. Let's try and get it right. Is this right here. So I'll have my R group. Do you break carbon-carbon single bonds? No. Carbonyl. Remember, this carbon is this carbon, which is this carbon, which is this oxygen. And what's my R prime? Notice the carbon with the hydroxyl group will be the carbon this oxygen's bonded to. So it's the center, second one of 4 carbons, because you don't break carbon-carbon single bonds. And that's how you do it. Now, one that totally confuses students, so I'm going to do it again, or better yet, let you try. If you take an ester reactor with 2 molecules or a Grignard, second step acid and water, you get 2 alcohols. The first one is this one. What's attached to the carbonyl carbon, R is still there. And this is very special. You make not 1, but 2 carbon-carbon single bonds. Something very special, very rare, and very good. And the other, this OR, becomes the second alcohol. And like I said, students have trouble with this. And here's one for you to have fun with. So have fun. And this reaction I will never give as a synthesis reaction on a test. And if you missed my announcement the other day, the rest of the semester, except for one slight modification of one general reaction, I won't be introducing you to any new general reactions, but we will be taking what you've learned out in the real world. And I forgot one thing. On test, I'd have a plus to tell you there are two things you need to put down. All right, I think everybody's done. So let's go ahead and do this. And how do you do this? You identify the functional groups. You look for what's different, what's not carbon, what's not hydrogen. Ooh, oxygen here and here, carbons and carbons here. We have an ester. And what are we reacting at first? To carbon-carbon magnesium halide. It's a Grignard. Remember, X can be chlorine, bromine, or in our case, iodine. And second step, acid. Remember, H plus means acid and water. And what do you get? What's attached to the carbonyl carbon is still attached. And then you make not one, but two carbon-carbon single bonds that becomes an alcohol, and this part becomes this alcohol. So if we look up here, this is R prime, and this is R triple prime. So here's our carbonyl carbon, that R group, methyl will be on it. I'll write it up here because I'm running out of room. This carbon will have a hydroxyl group, as seen here. Then what's my R triple prime? 3 carbons. Notice the N carbon here to the magnesium halide will be the carbon this carbon is bonded to. And we get this alcohol. And then this alcohol, what's our prime ethyl? And you'll get that alcohol too. And I'm going to be real nice, so don't tell anybody. Students have tremendous amount of problem with this reaction. Now, let's take a look at this. We have an amide, remember R prime, and our double prime can be hydrogen. Let's try that again. Can be, that looks better, hydrogen. And what do you get? You're an acid. So first of all, you get the carboxylic acid you would have used to make that amide, plus amine you would have gotten immediately reacts with the acid to make this amine salt. So what would be the organic product or products? And I should put this down for the following reaction. And I think everybody is almost done. And let's continue. And what's different here? What's not carbon? What's not hydrogen? Ooh, carbon with an oxygen, carbonyl, a nitrogen on that carbonyl. And I have carbons here, and here. Now remember, this is an amide, so R prime and R double prime can be, but in our case it isn't, but it could be hydrogen. And when you react it with acid and water, what do you get? You get back the carboxylic acid you would have used to make that amide, plus not the amine, because you're in the presence of acid, you get the amine salt. So if we come back here, R is methyl. One of these I'll call R prime, the other I'll call R double prime. So my R group is methyl. And I'll get acetic acid. And now the amine salt, one R group is ethyl, nitrogen, the other is a benzene ring. Don't forget to put the double bonds inside. And it has two hydrogens plus charge, and our anion is chlorine or chloride. And that's how you do that. Let's do one more. Well, let's do a synthesis. And let me remind you, if you take a nitrile, which has a triple bond between carbon and nitrogen, 2 pi bonds, 1 sigma, reacted with excess hydrogen, a catalyst. The catalyst can be nickel, platinum, or palladium to break the 2 pi bonds, and each atom of the triple bond gets a hydrogen, 2 hydrogens, and you make a primary amine. And there you go. What would I react with excess hydrogen? Remember, X and S in a bracket means you have all the hydrogen in the world that can react with anything hydrogen can react with, and a catalyst to make that compound. What would be the starting material? All right, it's time for me to get going. And the question is, what's the starting material? What do you react with? Hydrogen excess and platinum to make this compound. What's different? Ooh, nitrogen and a carbon. This is a primary amine, which I can write like this. Or, as in this problem, I can write like this. And what do we react with hydrogen excess and a catalyst, where the catalyst can be nickel, in this case, platinum, or palladium? And the answer is nitrile. Now, this carbon here is this carbon here, which is this carbon. So what's attached to it is the R group. And that's my R group. So what's my R group? A T-butyl group. And then I'll have this carbon, this nitrogen. And I know there are 4 bonds to carbon. And if we take this molecule and do this reaction, you'll get that product. And that's how you do it. And I thought I'd go through a couple of problems that students have trouble with on test 3. And give me a second, actually more than a second. While I'm doing, you can go back and look at this, while I open up something I need to open up. And guess what time it is? Oh, I'm going to do it again. It's lab time. Now, unfortunately, today's lab, I wish we were face-to-face at ECC because it's a fun lab, but we're not. The joys of a pandemic, but at least you'll get a feel for what would be very fun face-to-face. Today's lab deals with carboxylate anions and esters. Let's talk about esters. Esters are an important part of nature. They're responsible for many of the odors and also taste of fruits and vegetables and flowers in our daily life. And they're also used to make polymers. Now I'll talk later about carboxylate anions. Now, in part 1, you're going to be making, if we were face-to-face, a number of esters. And what's the reaction to make an ester? You take a carboxylic acid, react with an alcohol with acid, you'll make an ester. Now, today's lab, you would have been making esters and then using a very, very sensitive analytic tool, your nose, and you'd be smelling them. And that's what you would do. Let's look at today's lab, first part. And part 1, in part 1A, in 2 separate test tubes, you put 1 milliliter of glacial acetic acid. Now, the term glacial, I don't know how it came about. It's only used for acetic acid that I know of. That means it's 100% acetic acid. Now, next time you're at home, smell a bottle of vinegar. You say, wow, that's got a kick to it. Well, that's only 4%. Glacial acetic is 100%. and you sure don't want to smell that. It'll put you on your back on the floor. It's that strong. But anyways, in 2 test tubes, each one, you'll put 1 milliliter of glacial acetic. Next to 1 test tube, you'll add 1 milliliter of ethanol. To the other test tube, you'll add 1 milliliter of 3-methyl-1-butanol, common name isoamyl alcohol. You'll tap it like this. Remember, when you mix things, let me get something. Assume this is a test tube. Never ever mix it this way. Take it 1, 2, 3, 4. Don't tickle it, and that will mix it. Then in a fume hood, all our work we do in the hoods. Now, I would be warning you now, we're going to be using sulfuric acid, concentrated sulfuric acid. If you get it on your skin, you'll get an acid burn. This lab, all students are wearing gloves. We always wear safety goggles in the lab, but I also have students wear gloves. And for this one, I also tell students to wear long sleeve top or shirt. That's to protect your skin from sulfuric acid. In case you get some on there, that will protect it. Now, you'll add 1 milliliter, and we use eyedroppers for this approximately, and then place the beaker in warm water, 50 degrees C, for 10 minutes. How do you get warm water? Take a hot plate, put a beaker of water on there. Don't forget the boiling chips, just in case it shouldn't boil, but you always put boiling chips in a beaker of water on a hot plate just to be safe. And as soon as you see a few bubbles at the bottom of the large beaker, turn off the hot plate, but keep the beaker on the hot plate, and you'll find that's about 50, 55 degrees C. You'll put it in there for 10 minutes. Then for each test tube, you'll put the mixture, say test tube number 1, in about 50 ml beaker with about this much ice in the bottom. You'll stir it, you'll take it out of the hood, and you'll smell it like this. Never stick your nose in a beaker. 1, there's acid in there, dangerous. And 2, you don't know what kind of vapors are, and you smell it. And you do the same thing for the second test tube with the methyl iso 1-butanol isoamyl alcohol, and you'd write down what it smells like. And if we were in the lab, the first one where the alcohol with acetic acid is ethanol, it smells like nail polish remover. And the second one, now I'm really sad because it's fun to walk around the class. What do you smell? And they're surprised and said, wait, it smells like banana taffy, Laffy Taffy or whatever it is. And it smells like a banana. Now, notice here, I asked you to draw the structures. And when the students first smell this, wow, I'm not sure. And I say, hold it way away from your nose and smell it. And all of a sudden the light goes on, their eyes go, I don't know about that much, but, oh, it's a banana. Now, why? What is the problem when they first smell it? And it sort of smells familiar. Well, that's because in a banana, the ester you're smelling is just a small amount. In that beaker, the vapors coming out of the ester is a large amount. And guess what? It confuses your nose and brain because there's way more than they normally would smell. But anyways, at that point, I tell and ask students, where do you think the term artificial flavors come from? That's because they make the esters chemically. They don't isolate it from a banana. All right, second one, you'll take salicylic acid and add 5 milliliters of alcohol. The acid is a carboxylic acid, 5 milliliters of methanol, and again, mix it, add sulfuric acid. And remember, let me explain, because I haven't really, in this reaction, H+ is an acid. And the normal acid we use in organic for the labs is sulfuric acid, H2SO4. Now, there are other acids in commercial applications that organic chemists use, but we don't really use them in a teaching lab. Example, methane sulfonic acid, toluene sulfonic acid, which I really didn't talk about this semester. And now you'll mix two together, put it in the beaker, in a warm beaker. Now this one takes a little longer, 15 minutes. Then at the end of 15 minutes, pour that into a small beaker with a little ice and then smell it. And when the students smell this, they go, whoa. And what they smell is something that smells like mint or mint lifesavers. And guess what? You've made that. Methyl salicylate is what you smell and taste in mint lifesavers. Again, I ask you to draw the structure here. Now, in part 1C, what you'll be doing is add, again, acetic acid. Glacial acetic means pure acetic acid, half a mil, 1.5 milliliters of 1-octanol, mix it, and then add 1 milliliter of sulfuric acid, put it in a test tube or in the warm water for 20 minutes. Usually when I teach this lab, I should someday rewrite it. I say do part C first, then B, then A, because those take the longest, get those started first. At the end of 20 minutes, students put the mixture into a clean beaker with some ice, stir it and smell it. And they say, whoa, what does that smell like? And most of them say it smells like an orange. It has a fruity smell to it. And this is the main ester that you smell from oranges. Again, draw the structure. Now, the second part deals with carboxylate anions. And here I get into something you never thought I'd talk about, and that's diapers. Yes, diapers. How many of you have ever seen in a supermarket or big box store or used, if you had to diaper a child, and that is super absorbent diapers. And it's a billion-dollar industry. I mean, super absorbent chemicals, also known as polysodium acrylate, and that's used in the diapers. And this absorbs a large amount of urine. What is urine? Water mainly. And how does this happen? Hydrogen bonding. Now, in this lab, you'll be investigating the interaction of polysodium acrylate with water and hydrochloric acid. This will allow you to test whether I'm lying to you about hydrogen bonding. And as I remind people, HCl, hydrochloric acid, is a strong acid. Sodium hydroxide solution, strong base. Now, what you're going to do is take the sodium polyacetate, and that has this structure. Where N is on the order of about 1 million. And here we have a carboxylate anion. And I didn't mention in class, but I now will in lab, that hydrogen bonds extremely well to water. Now, the first thing you're going to do is put some in water and observe what you get. And when you do that, if we look at the data, in beaker 1, it becomes a gel. And beaker 2, you'll do the same thing. Now, what you're going to do is, in beaker B, take this with water and add some hydrochloric acid water till the pH is acidic. And what's the reaction we're doing? The carboxylate anion is a base, HCl is an acid, you get back the carboxylic acid. And now what you see at this point, right here in beaker 2, when you add the acid, it becomes a liquid. Why? Because it no longer really hydrogen bonds that well to water. Now, the last part, you'll add enough sodium hydroxide so the solution is basic. And what's the reaction? Carboxylic acid, base, and you get back the carboxylate anion. So if I take this now and react it with sodium hydroxide, now I don't really have water. Oh, this is in solution. So yeah, you'll get this carboxylate anion, which once again is better at hydrogen bonding. And when you see that hydrogen bonding, it looks like a gel. And I think certain floating candles, they sell this, put it in water, and then it becomes a gel. And then you can float candles on it. It's really nice. I've done it. Now, here are the questions you'll do. Now, one of the things I do in class or in the lab is I have some diapers that are super absorbent. I take one apart. You can see a little bit of cotton, real thin, or some fiber. Then all this powder in there. If you go like this, it'll come right down on a piece of paper. I'll take that, put it in a beaker, put in a little water, and you'll see it just become a gel. And that's how a diaper works. And for women, that's how you have the super absorbent feminine products to absorb blood, which is mainly water, when a woman is her monthly time of the year. So if you have a sanitary pad that's super absorbent, real thin, that uses that same technology. So next time you see either a super absorbent diaper or a super absorbent sanitary pad, we're talking very sophisticated organic chemistry. And with that, since I'm ahead and we're on track for everything, I can say, gang gesund, goodbye. I'm done for today. Don't forget, if you're coming to my office hour today, I'll be sending out an email and changing the links in the next hour for tonight's meeting. With that, I'm done. Gang gesund. I'll see you on Monday. Don't forget, do the practice problems if you haven't. Study, because test number 3 is coming up a week from today. Have a nice rest of the week. Gang gesund. Bye. I stole that from Granny.
Thank you.